So try to recall back. When we learn chapter 1, we assume that all numbers are positive, right? So we do not mention about negative numbers. Actually, a binary number can be represented as either a positive or negative value. So the common representation of sign numbers is either in the form of sign and sign magnitude or in the form of two's complement. Okay, so we have two approaches to represent uh, sign numbers. Okay, the numbers that have positive or negative values. Okay, so we have the first approach is sign magnitude. Second one is two's complement. So first we try to look at the first one, sign magnitude. In a sign magnitude system, a number consists of two parts, the magnitude and the sign. Okay, a sign bit 0 signifies a positive number and a sign bit equal to 1 signifies negative number. Okay, next. So sign magnitude representation, however, not commonly used in practice for representing integer numbers because it requires arithmetic circuit that are most costly and slower computation time. But for our learning purpose, we are going to learn this approach also. Okay, this is if you refer to the slide. Okay, so for example, you have 4 bits number. If you consider sign magnitude representation, the leftmost bit, okay, bit yang paling kiri, leftmost bit will be the sign bit and the rest will be the magnitude. Okay, the value. Magnitude means the value of the number. Okay, the sign bit either positive or negative. So if the number is positive, it will start with 0. If the number is negative, it will start with 1. Okay, so we can refer to this figure. For example, we want to represent a number. Okay, a number with length 4 bits. Okay, so only 3 bits will represent the value and the leftmost will be used to represent sign bit. Okay, for example, you have plus 0 until positive 0 until positive 7. Okay, so to represent positive 0, we write it as 0 0 because it represents positive, then the rest will be the value 0 0 0. Okay, same goes to positive 7. So start with 0 to represent the sign, positive sign, and then the rest will be the value 7. Okay, in binary, try to recall back. Okay, 7 will be represented in binary as 1 1 1. Okay, next. Let's say we want to represent the negative part. Okay, it will start with negative 0 up to negative 7. So for negative 7, we will represent it by 1 1 1 1. Okay, so the first leftmost bit will be the sign bit. Okay, 1 to represent negative. Okay, okay. Next is two's complement number. So we settle the first approach just now, sign magnitude. This one, two's complement number. Okay, two's complement number invented to make addition and subtraction faster and easier by omitting sign and magnitude comparison. So a negative number in two's complement is obtained from a positive two's complement number by complementing each bit, including the sign bit, and then adding 1 to it. The carry that occurs out of the MSB. MSB is most significant bit, okay, is discarded. Okay. So what is MSB? Okay, so MSB is most significant bit. Okay. Okay, so for sign numbers, okay, so I try to put it in a mind map. Also for sign numbers, we have sign magnitude approach, and then this one is two's complement. Okay, we will see later in details using exercise. Okay. Okay, let's consider this slide. Okay, number 2, show how an 8-bit computer would represent a two's complement number for positive 22 and negative 22. Okay, so we have 8-bit computer. Okay. Okay, so first you use your calculator to find a value of 22. Okay, 22. Okay. Okay, 22. Then this is positive number. Okay, this is positive 22. Okay, how to get negative 22? Okay, to get negative 22, first you have to inverse all bits. Okay, from this. Okay, 0 becomes 1, 1, 1. Then 1 becomes 0. 0 becomes 1. 1 becomes 0. And then this one 1. Okay. Okay, step for creating two's complement number. So first write the value in positive. Okay, this one use calculator. Convert decimal to binary. Second step, inverse all bits. Okay, 1 to 0, 0 to 1. Then last one, add 1. Okay, so okay, this is step 1. Okay, this is step 1, step 2. Then step 3, you plus with 1. Okay, step 3, you plus with 1. Plus with 1. 1 plus 1, 2. Carry to the next. 0, 1, 0, 1, 1, 1. Okay. So this is the answer for negative 22. Okay. Okay, let's consider the next question. Determine the decimal value for the following two's complement number. Okay, we have A, B, C. Okay, first, the tips here is when you see the question, okay, if the question mentioned two's complement, okay, then you have to check the first bit for the number. If the number start with 0, it means that the number is positive. And if the number start with 1, the number is negative. Okay, so for A and B, the number is I think the number is the same, exactly the same, right? Okay. Maybe the typo. Okay, let's solve only A. So A 001000010. So you just use your calculator and convert. Do the binary conversion from binary to decimal to get the decimal value. Okay, so this will be 30. Okay, kalau saya congak ni 30. This one 2 to the power of 5, 32. This one 2 to the power of 1. So 30, 34. Okay, so since the number start with 0, the answer is, okay, for A, positive 34. Okay, okay, what about C? Okay, C, if you look at the number given in C, the number start with 1. That's mean the number is negative. But how can we get the decimal value? Okay, if the number given is in decimal, we convert it to binary, then we inverse, then we plus with 1. Okay, but now if given in binary, negative number, how can we get the value in decimal? Okay, how many ones do we have here? 8 ones. Okay, let's try solve it. Okay, for this one, you have to write the number first. Okay, the number just now 1, 2, 3, 4, 5, 6, 7, 8. Okay, since the number leftmost bit start with 1, it is negative number. Okay, we know that it is negative number. So now our target to find its value in decimal. Okay, so what you have to do first, okay, this approach is for 2's complement number. When the question mentioned it is 2's complement number. Okay, so first step, you inverse all bits. Okay, so inverse, I inverse 0, 0, 0, 0, 0, 0, 0, 0. Second step, add 1. Okay, so this is the first step. Second step, plus 1. So okay, so from here we know that the value equal to 1. Okay, but remember to add the uh, step 3, get the value. Okay, write negative sign in front of the value. Okay, so just now you have value 1 here. Okay, so final answer, okay, answer equal to minus 1. Okay, so most of the students, they forget to put the minus sign. Okay, so if you just put 1, it is wrong because this is just the value, but the number actually negative 1. Okay.